Double click or drag, doesn't matter.
How old BMS? We're still using or we're not using that anymore at least?
Not using it. You
Not-
don't need it. The third chiller is
I
not
mean,
on there.
but it's still there, right? We
So,
just
but
don't
we're
touch
gonna delete
that.
it.
Okay.
No, we need it because I don't see secondary pumps. For
You see the secondary pumps.
Okay.
Go up to the top, enables to the system, toggle that to true.
And he's an expert.
Dimitri knows.
I did it many times.
It's gonna do that automatically. No.
How can we see
Oh, no.
secondary pumps in the building?
Put one or two in maintenance mode.
No, this is
I got you. And then you go right here.
for building 8-9.
No, this isn't linked yet. The towers.
So now what we want you to do is, you'll see the green part of the chiller turn to blue when the chiller's on. When the chiller actually comes on, but you'll see which valves are open. So chiller number 1 is your chiller. So click on the pop down right next to the chiller. There's a pop down, and that'll give you. And then you can open that up, and that'll give you all the chiller info. No, you don't have to scroll down. You can open it up, make it bigger.
Yeah, you could expand it.
Go down to the bottom line.
No,
Right
press
there.
the end.
Now drag that down.
Yep.
Now all your information on the chiller's there, so just watch the full load amp start going up as the chiller loads. Can you open up the VFD and tell me if you have any individual points on the VFD? There you go. Look at that. He's got it. He's a pro. So that's all. You know what I told you about software points from the drive? That's all the points available. So if someone wanted to do power calculations or how much you're doing in the building,
But we're not changing those points, right? We just
No.
see it and it is.
Yeah,
and
you
it's-
ju- you
this
can
is
just
a-
see it.
It's just information.
Yeah.
correct. That's correct. So then hit the back button. There you go. So now you know if it's an alarm, it could tell you the alarm number on that page, so you don't have to actually go to the drive.
If it's here alarm,
But you could see it's alarm if it's an alarm or not.
yes, now it's a normal, but again, if it was alarm, right? Then
Right.
go here.
It'll tell you the
We will
alarm.
see where is it, right?
Anybody
Yeah.
wants to change their username.
But the thing is that you should, when it has alarm there, you should actually check it in the field.
Because you have
You know what I mean?
No, it's okay, it's fine. It will be, at least we know why is that alarm.
Right. Now you can go over, see where it says commands and status on the top.
Two other people
Yes.
besides
Stop.
myself.
No, on the right. All the way right there. Now open up that window more. Right? So that'll tell you when it says chiller rotate. So right now, if we hit that, it made it true. Don't do it.
Yes, it's
Right?
gonna-
Number 2 will come on. Here's the panel. Here's the panel layout. This is an existing panel, but I wanted to show you what an NCE is, and these are the IOMs. The difference in this, one's bigger than the other one. This just has more IO count. Right? IO, remember input output?
Yes, yes, yes.
All right, this just has more inputs and outputs than the other one. So when we only need a couple of ports, we have smaller ones and we have bigger ones. So remember, this communicates, right, to these. This wire goes from here to here to here and gets all the information.
Through the SA bus.
Yes. This is a Cat5 cable that goes to the network switch, which is in here, which links the computer. So these are all the big, remember I told you the big ones? These are the big ones? The big ones all communicate on Cat5, right? And this is the SA bus, which links this to that.
You said that one has a 5,000 point limit?
Yeah, well, yes, 5,000 points.
NCE, right?
Right, NCE and the NAE, which is in that panel. So it's 5,000 points or 99 per loop. And remember, the difference between the NAE and the NCE, this has 1 loop, the NAE has 2 loops. So when you're getting to the new building, they'll all be NAEs because we need those loops to get all those 485 VAV boxes in. All right?
All right, so this one has, what, we have 3 IOMs.
An FEC on the bottom. I don't know what really the purpose of that is, besides for probably memory and.
That's it, it's just memory.
But as you can see, you got all your wires labeled. So on the bottom here, you got labeled to what terminal it goes to on your terminal strip. And then on your terminal strip side, you have what input or output it goes to on the actual controller itself. Obviously, you got your transformer up here, resets on there, another transformer here with a reset as well. This is your rectifier. This is what we're using for our DC power. So anything like with a 4 to 20 milliamp signal will be coming off of this. So for any reason any of your temperature sensors or anything like that go out, you want to check to make sure that this is good or this fuse isn't blown. Because that's a lot of times when you see multiple temperature sensors go out, it's because your rectifier went bad or a fuse blown. Other than that, you got your relays down here, which I think are being used for the valves up on the cooling towers. And those are just to trigger the 110.
The relay's labeled? Which one is
The relays are labeled by number. The numbers you can reference on the actual drawings themselves.
You want to open up the other one? You want to go into the batteries, the controllers?
Oh, the batteries?
Yeah.
Well, these don't have batteries. These don't have batteries. The NC has a battery.
Is
They're
there
really-
any case where
nothing
there
really.
could possibly, it sounds like a dumb question, where it'll be a point overload for the NCE?
As far as an overload, what do you mean by overload? Like they're not ran out of points?
Yeah, that it,
Or
ran
when-
out,
when
that
you-
doesn't have no, it has
Oh, it has no space for, say, a particular point. Like you
Yeah.
got your BOs and your AOs
Yeah,
and your.
and then all of a sudden it just, somehow, some way, it feels like if it's picking up more points. And there's
No, because
space for it.
you have to define where your points go on the list.
Okay.
So if, say you have a BO, but there's no BOs available, you could use a CO. But if a CO is not available, then you're gonna have to add another controller,
Okay.
which would be an IOM.
All right.
But you have to add those in the list actually in software in the CCT program. You can't do that from the head end.
Okay.
One of the things
So-
I was saying downstairs was you could add up to 7 IOMs to one controller. And the reason for is you limit out the memory and the speed of the controller if you went past that. You know, you bog the whole system down.
And as far as these, well, on the NC you got these lights. The fault light, when you see a flashing fault light, it could be a bunch of different things. It could be internal board temp. It could be you're near the capacity of the memory in there. There's a couple different things.
Box itself, right?
Just on this box itself,
this
yeah.
box
But there's
Oh, on
no
this
way
system,
for
yeah.
us to know that. We would have to.
You could
guys
go
would-
through the head ends, and it'll give you kind of like a breakdown, like a diagnostic on it.
Okay.
But you're not going to know what the limits are unless you look at the actual literature.
Okay.
So,
But
we
not-
could get you. I could get you that. That's not a
Is
problem.
that something that we're supposed to?
No, that's something more along the lines of a service
That's what
service
you go in
contract.
there and
But I'm just saying, don't get nervous if you see a fault. It doesn't really, unless you see a solid red light, it means you probably dumped your memory and you have no program in there at all.
Actually, if it's a dump and not splashing, it's a problem.
If it's a flashing, it's a it's more like an alarm. If it's solid, it means you probably dumped your memory and that the thing's not functioning.
Actually, that box itself, on this moment, it's not working, right?
Yeah,
If
we'll be
it's
getting
not
question
flashing,
marks
then-
on
Yeah,
everything.
if it's solid red,
Yes, it's
then
not
it's
working.
not working at all.
If you have an issue with the battery on these, they tell you. I don't know, they don't tell you on these, but on there's no battery in this actually. But this one, it'll tell you if there's a battery fault, and then your battery's under here.
And they suggest every 3 years you replace the battery.
And then this is just your connectivity lights. What speed you're running at and what speed you're running at, making sure you got your Ethernet blinking, means you got connectivity.
Burned in memory. So things like certain programs, certain things, what address am I and everything are burned in the EEPROM. That battery keeps the EEPROM, so when you lose power, it helps keep that memory. Like right now, if you pulled the battery out, it wouldn't do anything only because you're a live power.
Yeah. That's why, like, if say you had a reset, this like went into a fault, and you tried to do a reset, and you shut the power, it's gonna stay on. You're gonna have to pull the battery and put the battery back in. See how it's almost if you look, even look at the the lights on there. They're the identical, the same lights. But you have two blue connectors, which means two different trunks. Which means you can put a lot more devices on this.
Right, so if each one of these can hold 99, right? This one can only hold 99. That's
This one connected to that one, right? From this one.
yes, via the network switch.
Yes, this one.
Whenever you see a cat cable, it's always going to come back to a network switch. A network switch back to the computer.
One of these, which is from two of this one, which is the main one, which is
There is no real main one.
There
They
is.
all,
Depends.
so what they
goes
do,
between two of them, right?
right, so what they do is on the network, each one has an address. Address 1, address 2, address 3. And it keeps pulling through each one. And what they do is the speed at which they do that is called the baud rate. Okay? The baud rate I think is 32.9, 32,900 kilobits per second. 32.8.
34.
So that's the speed at which that bus goes around.
You really don't care about the baud rate.
Yeah, I was just saying, but it's a trivial number,
Yeah.
but that's what it is. So we wanted to show you how these interact with that, and on that drawing you have, you're gonna get that exact drawing is your drawing in the submittal. And when we go out to the panel, like what we were saying, how this is the cooling tower, this was existing. We needed more memory, so we added this panel. The chiller plant, we're gonna go outside and we're gonna show you how we had to add from these IOMs, this communication cable, see how there's two of each? Goes out to the panel outside to the chiller
It's the
plant.
same concept of what the cooling tower is doing.